Determine the intersection point. There are three cases that you need to consider. The first case is when you need to find the intersection point between a line and the two axes. Take note that when the line meets the xy plane, that means the z should be equal to 0. When the line meets the xz plane, y should be equal to 0, and when the line meets the yz plane, x should be equal to 0. The second case is when you need to find the intersection point between two lines. In this case, there are two possibilities of answer that you may obtain. That is either no intersection at all, or there is only one intersection point. Shouldn't be more than one intersection. The third case is when you need to find the intersection point between a line and a plane. For this case also, you may get either no intersection or only one intersection point. Refer to example 24. You need to find the point in which the line L1 meets the xz plane and the point of intersection of L1 and L2. When L1 meet the xz plane, that means y should be equal to 0. Substitute this into the second equation of L1, you will obtain negative t plus 2 equal to 0. Simplify, you will get t equal to 2. Substitute t equal to 2 into the first and the third equation and simplify, you will obtain x equal to 3 and z equal to 5. Combine the x, the y, and the z values together, you will obtain the point 305. So this is the point in which L1 meets the xz plane. To obtain the intersection points between the two lines, first you need to make sure that both equations of lines are in the parametric form. Then equate the corresponding component, you will obtain three simultaneous equations. Simplify the first equation, you will get s equal to 2t minus 3. Substitute this into the second equation and simplify, you will obtain t equal to 7 over 3 and s equal to 5 over 3. The third equation is used to verify the answer. Substitute the values of t and s inside the equation and simplify. As both sides are the same, that means it is verified. In other words, L1 and L2 are intersect. To find the intersection points, substitute either t or s value into the corresponding equation of line. Here, we substitute t into L1. You will get x equal to 11 over 3, y equal to negative 1 over 3, and z equal to 6. Combine x, y, and z values together, you will obtain 11 over 3, negative 1 over 3, 6 as the intersection points between L1 and L2. Take note that you need to use the equation that you have not used in finding the s and t to verify the answer. If let's say both sides are not the same after you substitute the two values inside, we can conclude that the lines are not intersect, meaning there is no intersection point between the two lines. Refer to example 25. You need to find the intersection point between a line and a plane. To obtain the intersection point between a line and a plane, first you need to make sure that the equation of the line is in the parametric form. Then, substitute the x, the y, and the z terms accordingly into the equation of plane and simplify, you will obtain t equal to 2. Substitute the value of t back into the equation of line, you will obtain x equal to 9, y equal to 4, and z equal to 0. Combine these three values together, you will get 9, 4, 0 as the intersection point of the line and the plane. If let's say the parameter t is undefined, we can conclude that the line and the plane are not intersect. meaning there is no intersection points. Refer to example 26. You need to find the angle between the given two lines. First, you need to obtain the vectors from L1 and L2, that is by taking the coefficient of the parameter t and s. From L1, V1 is equal to 2i plus 3j plus 4k. From L2, V2 is equal to I plus 2j minus 4k. Next, find the magnitude of V1 and V2. The magnitude of V1 is equal to the square root of 2 square plus 3 square plus 4 square, which is equal to square root 29, and magnitude of V2 is equal to the square root of 1 square plus 2 square plus negative 4 square, which is equal to square root 21. Then, find the scalar product of V1 and V2, that is, V1 dot V2 is equal to 2 times 1 plus 3 times 2 plus 4 times negative 4, which is equal to negative 8. Substitute the answers into the formula of theta, which is equal to the arc cos of V1 dot V2 over magnitude V1 magnitude V2. It is equal to 133.95 degree. In the next lesson, you will learn about power series that is on chapter 3.